Welcome everyone to our first South Chapter event of Cyber Ireland for 2021. A special thank you to our South Chapter leads for organising today's meeting and the high calibre of presenters that we have with us as well. We had a really active and successful year in 2020, and we've over 300 people actually signed up to the South Chapter mailing list. And the chapter leads have been working very diligently in the background over the last number of months. They have bi-weekly meetings, they've been running this event, and they have a number of other activities in the works as well. I'm going to hand you over to Eoin O'Neill, who's the South Chapter lead, who's put today's webinar together to give a bit more information around what the South Chapter has been doing and today's event shortly. But just first, I'm going to give you a quick update on Cyber Ireland's activities at the national level over the past couple of months. So our regional chapters, which we have in the South, the West and the Northwest, have been very active. In particular, our threat intel group has gone from strength to strength, which runs a monthly webinar the last Wednesday of the month, starting out with the introduction phase before Christmas, and it has since moved on now to the implementation phase of a threat intel program within your organization, with more in-depth talks around active defense and effective incident response. And then next week, on Wednesday the 28th, we have Derek Buchanan from CrowdStrike, who's going to be going through how to build a threat intel program as well. And they might post the link to that for anybody who's interested. We've been working on a number of policy submissions for government at both the national and the regional level. The NIS 2.0 public consultation was out a couple of months ago. As well, we made an input into the Commission on the Defence Forces. The National Cybersecurity Centre had a capability review that we inputted into as well, and also into national policy around the recovery from COVID-19 and the importance of cybersecurity for our country's digital transformation. And then at a regional level in the South, we've been inputting into the Southwest Smart Specialisation Strategy and the Cork Development Plan as well. On our skills initiatives, we launched our first cybersecurity skills report in February with over 200 attendees at that event. That was a survey of over 80 of our members to understand what are their skills needs, what are the skills shortages and the gaps in industry. And we've made a number of recommendations for industry, academia and government to address these challenges. But it wasn't all bad news. We also spoke about a number of initiatives addressing the cybersecurity skills shortage already in Ireland. In particular, the €8 million cyber skills project, which was being led by Munster Technological University and also includes University of Limerick, which over the next 5 years is going to create an online learning environment for upskilling and training and development for people in industry. We also had Cyber Women Ireland discuss their diversity survey. They've launched a new website and are working on a diversity toolkit to provide resources to address diversity and inclusion challenges in the cybersecurity sector. And then in collaboration with the Cyber Skills Project, we're running Ireland's first Cyber Schools Academy to train up the next generation of cybersecurity professionals. So this is going to include a cyber summer camp in June, career talks, and a national Capture the Flag competition for schools as well. On the R&D front, we've been working on securing specific funding for a collaborative cybersecurity R&D projects between industry and academia, and also promoting funding that's available for companies at the national and European level as well. We'll have a webinar coming up on Horizon Europe funding in May. And then we're also supporting an academic proposal for an all-island cybersecurity research centre. So that's a really exciting piece of work. And then finally, for Indigenous companies, startups and entrepreneurs, we recently joined the Global Epic Soft Landing Initiative to offer our members the opportunity to soft land for a trial period in a market of 13 cybersecurity regions and ecosystems around the world, from the UK to European destinations, the US and Asia. And this is all free of charge as well. So there's been a lot going on over the last couple of months. a lot of this activity is driven by you, the cluster members, so thanks for your support. And just to keep up to date on that, make sure you sign up to our newsletter for all of our events and our activities as well. We're also coming up to the 2nd anniversary of the launch of Cyber Ireland, which was in May of 2019. So just a big thank you for your support to date, and also the membership subscriptions, which allows us to do this work. So that's all from me. I'll hand you over to Emer to kick off today's webinar.
Thanks, Eoin. And thank you all for joining today, and welcome, as Eoin said, to our first Cyber Ireland South Chapter webinar of 2021. So before I introduce you to the webinar, I want to welcome some of our new chapter leads to the South Chapter. We have Paolo Palmieri from UCC, Eoin Wickens from Blackberry Cylance, Kevin Burke from Gardaí, and Richard Parker from Dell joining us in the South Chapter. So looking forward to some more events as we go through this year. So today we have a great lineup ahead of us with 4 lightning talks with the goal of sharing oversight into what is required to set up a product security incident response team, and also talk about the best practice around handling events similar to Solarwinds supply chain attack. We will run through 4 talks, and then at the end we'll have some time for Q&A. So we won't stop for questions after each talk, but I'll encourage people to pop in a question in the Q&A section here of the Zoom webinar as we go along, and the panelists will respond either during the sessions or at the end. So with that, I'm going to introduce you to our first 2 speakers, Pete Allor and Josh Dembling. Pete is the director of the Red Hat Product Security Incident Response Team. He's worked on incident response and vulnerability disclosure issues for the past 20 years, first at Internet Security Systems, then IBM, followed by Honeywell, and now he's at Red Hat. His work in incident response, policy formation, and standards work focused on sharing across the industry in support of industry ISACs, support to the National Infrastructure Advisory Council, and the Information Technology Sector Coordinating Councils. Pete has focused his efforts in product and cloud security, vulnerability management, coordinated disclosure, and incident response and orchestration. He worked on the CVSS standard development and protection profiles for medical devices. In addition to all that, he served on the first board of directors for 9 years and is now the co-chair for the first PSIRT security information group, SIG, with Josh. And in his spare time, he spent on his rowing machine or building remote control airplanes and crashing them so he can rebuild them. So that's Pete. And then along with Pete, we have Josh. Josh Dembling is the senior director of the Intel Product Security Incident Response Team and the Bug Bounty program there. Over a span of 3 decades, he has led organization transformations while at Intel, IBM, and Motorola. He specializes in product security, vulnerability response management, bug bounty programs, and security researcher outreach. Josh is a leader in technology industry groups where he drives collaboration on initiatives that encourage the exchange of ideas on solutions to product security challenges across the industry. He's the co-chair for the first PSIRT Special Interest Group and a host on the Security Unhappy Hour video podcast. Outside of work, Josh can be found taking long walks in the rain, which Ireland would be nice for, and dancing like no one, and hunting for unicorns. So at that, Josh and Pete, I'm going to hand over to you to talk about an overview of PSIRT framework, maturity model, and SIG.
Thank you, Amir, and thank you for allowing us all to come and speak with you today about PSIRT, or Product Security Incident Response Teams. We wanted to start out by, in our part of the Lightning Talk, how PSIRTs operate a little bit and what we're trying to do to advance our knowledge and share amongst ourselves. And so the first thing we get a lot of questions about is, what's the difference between a PSIRT and a CSIRT, or the Computer Security Incident Response Team? And I think the key part and differentiator is we're both in an organization. One is about protecting the organization, while the other is about how do we protect the products that we all produce and that our customers rely on. And so generally, that's the big difference. When we go to operate, we have different synergies and operating modalities. And so what that really means is when we looked at the CSIRTs and we started to define those through FIRST, we found that there was a lot of commonality between the National CSIRT and Enterprise CSIRT. We started to find that as a product security incident response team, and we found out that we were doing things differently. And while we synergized between each other, we found people were needing to focus on PSIRTs in a much different way. typically what happens is in a incident response for a product is that we're orchestrating a response for the entire organization. And that orchestration means that while we are directing things, we're actually getting others throughout the entire company to respond, whether it's in engineering, it's corporate communications, it's legal. Our job is to bring them all together and make it look as a smooth, simple process. So that's the result that people see, but what they don't see is the amount of work that goes on behind that. The other major difference when you look at it is from a PSIRT perspective, the tendency is that we have to respond in minutes and hours. And when you have an outage or a problem for a day, everything is a hair on fire emergency. For PSIRT, a lot of times we are working with others, either upstream in open source community or with a finder as they discover something. And we have a bit of lead time. Because it's an engineering practice, we actually have to develop new code, we have to test it, we have to then internationalize it, put it across several different languages, and sometimes coordinate with others in the industry. That time scale runs from days to weeks, sometimes months. So you find that while we move with a sense of purpose, we don't have an immediacy that has to be out the door in this next minute. That doesn't mean we don't have that problem. We do, because we are a quote 0 day from time to time. But when we work through that, we usually have a different time frame. The issue that most people don't realize is that if you're creating code, you're producing something on a website and people are using that code, or they're using an app or something that you've produced, you probably ought to look at having a product security incident response team. So as you look at that, we're saying there's a lot of things that you have to do in the way of quick actions, a lot of things you have to do in a pre-planned reactive mode. So you're reacting, but you have a plan ahead. And so as we look at that, and we look at the checks and balances you do with engineering, you have to think about it and outline it so they understand the need to respond and to meet the timelines. That's what we work on as a PSIRT SIG in formulating that thought. Previously, there was no real documentation. There's a couple books people have written, but it was more from a, here's what I have to do for this position, and here's what I have to do for the next position. We took it from a, how do you do a response from an organizational position? So that's what the PSIRT SIG tried to form around the PSIRT services framework. And that framework really outlines the different services and service areas that we provide to our organization, and what are the things that you have to think through as you build that process. Over time, we realized that to do that, we actually have to go deeper. And so we have continuing efforts around that. We've gotten so far 95 different separate PSIRT entities who are contributing to this effort. So what you're getting is, here's the state of the practice, the state of the art, and we're trying to find that for others who, quite frankly, haven't had a chance to look at it from a broad perspective, or to inform public policy people to understand how you have to think through this differently from the PSIRT perspective. That is encapsulated in the PSIRT services framework and in some of the plans that Josh will talk about in a few minutes. All this leads through how do you establish and work. And as you go through the rest of Lightning Talks, you'll see how they make that application all the way through to release. One of the things that we've learned about in the PSIRT services framework from the first perspective is we have a lot of people talk about capacity and capability and maturity. And we use those terms as if they're the same. And we've defined them as three different elements. First is a capability. Capabilities, can you do a certain set of tasks? The next is maturity. How well can you do them? Meaning, are you at a initial operations level, or are you a well thought through process and you can do this at the highest level of that service? And then finally is capacity. We could define capacity as how many simultaneous events can you withstand? All organizations have a capability to do things, but they don't always have the capacity to do multiple events simultaneously. And that is what stretches a lot of our PSIRTs, and why you need a larger, depending upon the portfolio you're supporting. So as we look forward in that PSIRT framework and trying to describe what it is that we do, and if you will, set up a more doctrinal template of how to organize, one of the things that we're moving from is the individual response. I know Josh knows me, therefore we can coordinate between organizations, to what is an organizational response? And that's the next extension that we're working on within the PSIRT community, is how do we organizationally respond and take our two organizations together and move it forward. So with that in mind, we look forward to the 2022 first conference in Dublin, and I'll let Josh talk to the rest of how we organize this.
Yeah, so I'll talk a little bit more about the future of the PSIRT services framework, which is the core of what we've done in the SIG. There's a lot of other activities, and I'll talk a little bit about joining the SIG near the end, but our vision is to evolve the PSIRT services framework into a series of layered documents that contain references between them. The idea being to provide a comprehensive understanding of the implementation of PSIRT. Well, the first layer, of course, is going to be our core, which is the PSIRT services framework, which is designed, as Pete pointed out, to assist organizations in building, maintaining, and growing their capabilities as a PSIRT. Now, the framework is a guide that identifies various models, capabilities, services, and outcomes. And in this way, teams are free to implement their own model and to build capabilities that meet their stakeholders' unique needs. Now, the framework seeks to assist PSIRTs in identifying core responsibilities, providing guidance on how to build capabilities to meet those responsibilities, and offering insights on how teams can add and communicate value to their larger organizations, which is often a real challenge for PSIRT teams. The second layer of documents include things like the PSIRT maturity document and other tools for maturity assessment. The PSIRT maturity document helps to provide companies with a set of characteristics and levels that enable a company to demonstrate and recognize operational capability and maturity in PSIRT. And the document will evolve to integrate more with the PSIRT services framework, and we'll look at opportunities to sharpen the usefulness of this. And ultimately, the document in this layer will serve as an overall practical guide for measuring the implementation of PSIRT services. Now, it's worth noting at this point that the maturity document is not a standard, and it's not meant to be used as a standard. Instead, it represents a series of use cases as well as a high-level overview of the services that a PSIRT might select at any point in time as part of their program. Now, the program may evolve over time as the mission needs change and as the experience of the team grows. Now, these reference use cases cover a spectrum of developmental levels, from a newly established PSIRT through a more advanced incident response team that has constantly refined its processes and added to their capabilities. As this evolution occurs, the team shifts from a reactive operation to a more proactive mode of operating, reflecting greater maturity of their process. Now, the third layer will contain a more expressive series of documents that builds out more detailed examples to implement the content in both layer 1 and 2 with respect to implementing PSIRT services. Consider that this will be made up of separate documents on specific topics. For example, scoping your PSIRT based on organizational structure, PSIRT model and corporate culture, conducting a post-mortem, the transitive nature of relationships between PSIRT models and stakeholders, like the relationship between CSIRTs and PSIRTs, or within your reporting structure. Now, these layers and the work that the PSIRT SIG represents is an opportunity to improve the ecosystem by bringing people together to share knowledge, experiences, and develop a common understanding of PSIRT operations and strategies. So if you are a member of a PSIRT team or you run a PSIRT team, we'd encourage you to consider joining the PSIRT SIG and contributing to this. Like I mentioned, right, we work together to develop and mature product security incident response. Our objectives are to further product security coordination and include the practice of vulnerability disclosure, incident coordination, release coordination as a means of jointly protecting the internet and organizational ecosystems. And the PSIRT SIG is open to all industry professionals that work on or lead PSIRTs. If you're interested in joining the SIG so that you can help improve the PSIRT practice or to learn from others while working on PSIRTs, then reach out to us. There's a link in that will show up in our chat to the PSIRT SIG website, and there's an email address that you can shoot a note to us. And that's it.
Excellent. Thank you, Pete and Josh. Very interesting and great to kind of call out the difference between PSIRT and CSIRT and some of the great frameworks and maturity models that are being worked out there. And I must say I'm very much looking forward to hopefully having an in-person conference in Dublin next year. Okay, so next up we have Kieran Boyde. Kieran is a Senior Security Response Technical Program Manager with the VMware Security Response Centre based here in Cork. He's been with VMware since 2007. Kieran first worked in the Global Support Services team as a staff engineer and then moved to product security in 2016. Prior to joining VMware, he worked in software development at Motorola. So Kieran's going to talk to us today about VMware's Security Response Program. Over to you, Kieran.
Thanks, Emer. Let me just share the slides here. You might let me know whether you can see them.
Let's see, we can see them, yeah.
Yeah, okay, so I'm going to talk to you about the VMware Security Response Centre where Emer and I work. VMware Security Response Centre was established in 2008, and we're involved in dealing with product security vulnerabilities in VMware software and services. So we are a PSIRT, much like Pete and Josh spoke about. We first crossed paths with the first organization in 2018. As it happens, I think Pete hosted a technical colloquium in Atlanta. And I suppose the great thing about being involved with FIRST is they're very much open to welcoming new people on board and sharing ideas with them. And it's a great organization to get to know how to deal with PSIRTs and all the challenges that presents. So we attended the technical colloquium initially, met with our peers, and then decided to apply for membership later that year. And applying for membership is a rigorous process. You got to sit down and look at your processes, your procedures, your standard operating procedures. Is everything in place as it should be? You then get a visit from industry peers to see that you're doing things as you should and progress from there. And it was a great learning experience from us to see what other people in other PSIRTs do and how they handle incidents. We proceeded to become full members at the end of 2018 and have been involved ever since. We're involved in the special interest group that Pete and Josh chair at the moment, and it's very beneficial to share ideas about how you get things done. So as of 2021, the team has grown. We're a team of about 15 people, which for a company the size of VMware doesn't sound too big, but we're part of the larger product security engineering team, and we have the ability to leverage members of security engineering and also R&D at any point to assist us with issues as they come up over time. We're composed of both security engineers who look at issues and program managers like myself who are responsible for handling the issues with all the various stakeholders, including the reporters, the development teams internally at VMware, customers, and so on. So where do these incidents come from that we deal with? I guess they come from three predominant areas. Security researchers is the obvious one, where individual security researchers can email us at security@vmware.com. Single individuals come to us with issues, but also larger organizations like ZDI or the Google Project Zero. Also, we actively participate in hacking competitions where we provide sponsorship for the likes of Pawn to Own, where VMware products can be a target, and we get to deal with the larger community of security researchers and get to know about the vulnerabilities as they're exposed. So that's one route where issues come to us. Of course, we're also, like any big software company, we're using a lot of open source software. So we have the challenge of ensuring that our products which consume open source software appropriately handle vulnerabilities reported in the open source environment, things like OpenSSL or JRE or struts or whatever. So that's an ongoing challenge, keeping on top of that. And finally, I suppose we have questions coming to us from customers through our support organization, Global Support Services. They can be as straightforward as vulnerability scans where out of date open source software may be identified, or other vulnerabilities. Customers may have teams doing penetration testing on their environment, or they may be asking questions about some of the security advisories that we issue on a regular basis. So these are the origins of the things that we need to deal with. So moving on, just talking through typically how do you handle a vulnerability report when it comes into our team. First of all, I guess we open a case to track the issue. Then we proceed to investigate. And I guess there's a bit of back and forth at this point. Our security engineers will try to reproduce the issue as it's been reported by the researcher. If we can reproduce it, well and good, that's pretty straightforward, but sometimes there can be issues, versions or proof of concept that the researcher has used hasn't worked for us, and we need to get to the bottom of it. But ultimately, we identify the root cause and we score using the CVSS V3 system to determine severity. We move on then, I guess, once we've agreed that there's a problem, we got to go through developing a fix. And there's a lot of collaboration needs to go on here with the development teams to ensure that the fix is appropriate. We provide assistance in verifying that, in fact, it does address the security vulnerability. And then we start working to decide how we can plan our communication. I mean, on the right-hand side, you can see the ultimate outcome of all of this is a VMware security advisory. That's released when the patch is released with the fix. And the objective of our advisories really is to provide enough information to our customers so they can assess the impact of the particular vulnerability to their environment and make a decision about how best to proceed. They may want to patch immediately, or they may want to postpone and wait for a maintenance window. They ultimately do the risk assessment. So the structure of our advisories is a summary of the vulnerability, detail of the CV associated with that, details of the fix. Usually there is a patch released. Sometimes also there would be a workaround for those customers who can't patch immediately. And the objective is to give as much information as possible to allow customers to make decisions about how they want to proceed without giving away too much about the vulnerability, and also making clear and concise information about how to remediate and address the underlying problem. So as our team has grown, I've mentioned working with our peers in FIRST, and challenges that present themselves are things that we found we needed to do to mature as a PSIRT are across tooling, policy, and metrics. And one of the things in tooling is having an appropriate ticketing system to be able to handle the issues as they come in. A recent project over the past 18 months, 2 years that we've been involved in is moving from a manual system where we were opening tickets manually to an automated system that generates new tickets as issues are reported into security@vmware.com. We've based that on Jira Service Desk, and we had a lot of conversation with other PSIRTs through FIRST to say, you know, what do you use? And it varied from, a lot of people did happen to be using Jira Service Desk. Others were using in-house developed custom tools or off-the-shelf software. We decided to go with Jira Service Desk because others had been using it, and we also had a project team with the capability to assist. We were using it internally on other projects, and they allowed us to customize it for our needs. The next item we've been working on is policy. And policy is important with, as I mentioned, we deal a lot with product development teams who need to develop a patch and deliver a fix. And it's important that they know what the expectation is in terms of when the security response center comes to them to say, look, there's a security vulnerability and we need a fix for it. As Josh and Pete alluded to, sometimes fixes can take days, weeks, months, time varies, but there is expectations in terms of we expect teams to look at the issues more or less immediately and start working towards a fix. But it's not just a case of the PSIRT telling the dev teams what to do. There has to be buy-in. So we've collaborated and discussed quite a bit to get buy-in from the development teams to agree with our policy for fixed delivery. I suppose the final one that's proven important is metrics. And again, lots of discussion with our peers on the PSIRT SIG about what kind of metrics they were using, how they were generating them. It's important for us to know how long is it taking us to fix issues from the point when an issue gets reported into the security response team to when a fix is actually delivered and a VMSA is published. How long is that taking? That's one key metric. Another key metric is in terms of the development teams. If we go to a development team today to look for a fix for an issue, how long does it take before that ships out the door? That's key. And we've worked towards having, initially we were considering service level hard numbers, but we're now looking at service level objectives, so that teams strive to achieve targets, but their objectives rather than hard numbers. And that's proving beneficial in that we see that we get more buy-in. From the metrics front as well, we're also looking at things like sources of vulnerabilities. Is it coming from penetration tests, vulnerability scans, security researchers? Is there particular products or particular areas of products that are particularly vulnerable to issues? Clearly, if there's a spike in issues being reported on a particular area, we need to get better in the product security scanning of the product before we ship it out the door. There may need to be a focus, there may need to be a hackathon or appropriate steps taken to address that. And that's it for me. Thank you very much.
Thank you, Kieran. Very insightful, and I hope it'll help folks on the call. Okay, next up we have Eoin Wickens. Eoin works for Blackberry as a threat researcher as part of their threat research team here in Cork. His work focuses largely within endpoint detection and response, building analysis, automation, and tracking emerging threats. Eoin recently graduated from Munster Technology University, formerly known as CIT or Cork Institute of Technology, with a BSc Honours in Computer Systems and multiple academic awards, including the IBM Prize. So Eoin is going to talk about supply chain attacks, a product security case study from an endpoint perspective. Over to you, Eoin. Thank you.
Hi, everybody. How's it going? Can you see my screen?
We can, yep.
Perfect. So as Emer said, I'm a threat researcher working for Blackberry's threat research team here in Cork. My talk today is titled Supply Chain Attacks, a product security case study from an endpoint perspective. Over the course of this talk, we're going to look at a few different things. Firstly, what a supply chain attack is, the potential impacts of a supply chain attack, and as an example, a brief case study of the recent Solarwinds breach. Instead of looking at the attack as a whole, we'll instead take a glance at some key features of the Sunspot and Sunburst malware, how they bypass detection on the endpoint, the impact this had, and what kind of detection and prevention can be put in place from both an endpoint and a PSIRT perspective. So to understand a supply chain attack, we must take a topological view of how companies interact. Supply chain attacks occur when an organization or company relies on a third party for part of their product development, be it for hardware, software, or something else. The US Department of Defense's definition of a supply chain attack, and this is quite a mouthful, states that an adversary may sabotage, maliciously introduce unwanted function, or otherwise subvert the design, integrity, manufacturing, production, distribution, installation, operation, or maintenance of a system to survey, deny, disrupt, or otherwise degrade the function, use, or operation of the system, which is quite succinct, really. So let's take a look at the diagram above. The organization depends on vendors A through C for different requirements. All is well until vendor C is breached and a foothold is established in their environment. Vendor C's product development lifecycle is infiltrated and a malicious function included in their product. The product in its hijacked state is now distributed to the organization dependent on that product and serves as a foothold for the malicious adversary to infiltrate and compromise. Once this is done, any and all information that they can access can and will be exfiltrated, such as product information, financial information, and personal information. Depending on how the security posturing of the affected organization is, further propagation of this attack may affect linked organizations. The potential impact of a supply chain attack can be huge depending on the customer base of the product, as the relation between the producer to consumers is essentially a one-to-many single point of failure. It can be taken that the larger the customer base, the larger the potential attack base too. It can prove quite difficult to determine with any degree of certainty which of your customers have been affected. even if they've installed the malicious function or feature. And as a result, as soon as the breach has been identified, customers should be notified so that they can begin their own remediation efforts. We must assume in these scenarios that the worst has happened, that the product consumers have been breached, and that the longer the time before disclosure and response to the breach, the greater the risk of a persistent foothold in their environment. And furthermore, there's that possibility of a knock-on effect, where if a breach is not contained, there's a possibility that other linked organizations can be affected too, as we saw in the previous diagram. So supply chain attacks sound pretty scary, and they are. The prospect of a trusted source being the point of initial compromise is one that we'd like to think won't happen, but they do, and when they do, they go with a bang. Some examples of supply chain attacks being the NotPetya ransomware, where it compromised a Ukrainian tax software called Medoc and caused around 10 billion worth of damages to giants like Maersk, and Solarwinds, where their Orion IT management and monitoring software was compromised and pushed out to a number of high-profile clients. And coincidentally, as of this morning, CodeCov, where a bash uploader script used by thousands of customers was found to take customer credentials, tokens, API keys, and anything stored in their environmental variables in their CI environments, and potentially affecting some more big-name clients. So today we're going to take a look at a high-level overview of the SolarWinds supply chain attack centered around Sunspot and Sunburst. So the SolarWinds breach was a sophisticated and highly complex supply chain attack, where the adversary tracked by FireEye as UNC 2452, compromised SolarWinds build servers, and was able to add malicious code into the SolarWinds Orion software. Malware discovered by CrowdStrike, given the moniker Sunspot, injected code into the build process in their servers, while Sunburst, discovered by FireEye, was the malicious DLL placed within their Orion software on the endpoint. These were some of the malware used, or only some of the malware used, but for brevity, I'm just going to reference them in the talk. Alex Hinchcliffe is going to be going into more detail with regards to Sunspot and the compromising of the CI/CD build process. So the number of affected organizations was huge, with SolarWinds announcing that of their 300,000 customers, 33,000 used Orion, with 18,000 having downloaded the malicious update. So let's look at a condensed and brief timeline of this attack. September 2019, the threat actor tracked by FireEye compromises SolarWinds. February 2020, the Sunburst backdoor is compiled and deployed. March 2020 is the estimated start of distribution of the malicious Orion management software. And finally, December 2020, where the supply chain attack was disclosed by FireEye. So what's obvious here is that the timeline for this attack is over a year. And part of what made it so devastating, the propensity for that knock-on effect that I mentioned previously is much greater, and the risk of other companies being compromised with footholds in their environments is quite high. So how did it bypass detection? At its core, a supply chain attack is an abuse of trust, a trusted supplier or vendor who we assume maintains rigorous security standards. An analyst that reads over C2 communication beacons in the network traffic that will have a certain bias towards the level of trust in an application. They might see a particular domain of interest in the network traffic, but since it's come from a trusted application, it's presumed that it is trusted. Not to put the fault on analysts, the attack was highly sophisticated. The function names and flow of the code appeared to blend in with the rest of the application. The names of the malicious C# class blended in with the rest, contained encrypted strings, had extended period of time between beacons, and a domain generation algorithm. By all accounts, it was quite complex. Not only this, the file was digitally signed with a valid certificate due to the manner in which Sunspot injected malicious code into the build process. Once again, we circle back to trust. We presume trust due to its valid certificate. We also presume trust in the software tooling of the software development lifecycle. And this is what makes supply chain attacks so formidable. Lastly, sophisticated measures were made in the binary of Sunburst to enhance its stealth on the endpoint. An example of this is block lists of different service names and internal lab domains, each being FNV1A hashed with additional XORs to evade detection. If any of these endpoint protection suites were found on the endpoint, or if it was in a SolarWinds lab, it wouldn't run. So what kind of an impact did SolarWinds have? Well, as we saw, 18,000 high-profile companies, including a number of Fortune 500 companies, and government entities such as the DHS, DOJ, and DoD were affected. The lengthy timeline of the attack meant that each one of the 18,000 affected customers had to completely reassess their security posturing and perform an extremely thorough sweep of their infrastructure and environments, and the full extent of this attack still isn't known. So reverse engineering the domain generation algorithm used within Sunburst gave us an indication of which companies were targeted, and while I won't go into details as to which were, a large portion were gigantic household names. So some benefits that came from this attack is that it revitalized the need to investigate and more thoroughly vet supply chain applications. While every company is going to depend on third parties for particular parts of their software or product development lifecycle, it's important that they're thoroughly vetted. Another benefit is due to the magnitude of the attack, is that it showed us that we need to be more aware of the threat of supply chain attacks. A chain is only as strong as its weakest link, and if one part breaks, the whole system can fall. So the question remains, how can we better protect ourselves in the future? I believe that we must take a holistic approach to security and cover all angles. Having one method of protection is not enough, and all bases need to be covered, including the ones we don't ever assume will affect us, such as these. Not only this, but having PSIRT and CSIRT teams there to help tighten security and remediate against events such as this are both highly important and necessary if we wish to implement better security standards going forward. PSIRT, working closely with other teams and communicating with them throughout the software development lifecycle within a company is also quite important here, with the PSIRT being more proactive as it reaches new maturity levels. This will help ensure that the products and build processes are as secure as they possibly can be, and that the line of communication between teams are well formed, so as to reduce the time taken between communication and incidents such as supply chain attacks from occurring. From an Allor's perspective, we need to weaken the trust bias we have towards trusted applications and services. We should place some value in certificate signing, provenance, build tooling, etc., but it's good to not blindly and implicitly trust. We must always remain slightly skeptical, even though that is quite a hard ask. And furthermore, one of the most important things to prevent this domino effect or knock-on effect from occurring is the rapid containment of a breach and the rapid disclosure of a breach, so that both your organization and the organizations that rely on your product can rapidly contain the incident. And finally, an important step for any organization is to join a special interest group like the first PSIRT SIG, started by Peter and Josh, who's just spoke before me, and consists of an assembly of active industry practitioners driving the evolution of PSIRT practices. And this is done by developing and maturing product response through collaborating to bridge the knowledge gap between vulnerability and response aspects of product security from newly formed to well-established teams. So thanks, everybody. Hope you're all able to get some of this talk, and thanks for your time.
Great, Eoin. Thank you very much. A very insightful presentation, and great to see those benefits called out there as well. I think this is all in our own hands to how we mature and evolve from learning from these supply chain attacks. So our last speaker today is Alex Hinchcliffe. Alex is a threat intelligence analyst in Unit 42. His main responsibilities include research into threats, the groups behind them, their motivations and tactics. He started his career as an intern at the Dr. Solomon's antivirus company in the UK, and some years later in McAfee Labs, he co-created the industry's first cloud-based anti-malware reputation system. Alex regularly speaks about threats Unit 42 discovers and participates in some public and private industry working groups. So Alex is going to talk about SolarStorm Threat Brief. Over to you, Alex. Thank you.
Hi there, thanks very much for the introduction, Emir, and great presentation by Eoin there, teeing up my slides very nicely with regards to the same topic. So hello everyone, a pleasure to be here to talk to you today, and thanks for the invitation and for your attention in this last lightning talk today. So I'm going to go through this pretty rapidly, but the material will be shared afterwards, so hopefully if you missed it or if you want to recap, there'll be time to do that as well. I'm sure many of you heard about the fairly recent Solarwinds attacks from last year, especially in the last presentation. But as Eoin said, there's still many things that are unfolding now. We're learning more about the attacks. We're learning more about the victims of those attacks. So still lots more to learn as well. Two main goals today. One is to hopefully give you something new that you didn't already know about these attacks. Eoin's done a great job of teeing that up already, but hopefully there's still some other things I can provide. And then secondly, to give you some idea of the challenges a PSIRT would have in facing such a sophisticated attack. So if you imagine you were the PSIRT in SolarWinds, the kind of challenges you would have to face. So without further ado, the SolarWinds attacks of 2020 and 21 were pretty big. There's a lot to unpack there. So just firstly, at a high level view, I'm going to try and bucketize a few different things that happened so we can better understand them. So first of all, there's what we call in Unit 42 SolarStorm, which I think is the unknown 2542 name that we mentioned, and a few other names from different vendors. But that's the activity, or the name that we're using to track all the activity related to this supply chain attack that happened using the SolarWinds Orion software. It affected 18,000 odd customers, as was mentioned, including Palo Alto Networks. We actually were affected through SolarWinds Orion. Luckily, our software prevented the Cobalt Strike secondary payload from running, but we were a victim. And generally speaking, the objectives of that group, SolarStorm, were to spread and get deeper access into the network, to get access to the cloud if possible, adding federation trust to Azure AD, exfiltration of data by adding credentials and certs to OAuth applications like Mail, so they could read them remotely. Secondly, it transpired afterwards that there were victims of the same attackers, so SolarStorm, but they didn't use SolarWinds Orion software. Their clouds were attacked. So specifically, a few companies came out and said they were. Malwarebytes was one of them, Mimecast another, but I think they've said that they were affected by Orion now, and CrowdStrike as well. CrowdStrike said their attacks failed, but I think Malwarebytes had said that there was some success on the attack front, but it was kind of limited in damage that was done. But the attacks were done through legacy applications in the cloud, poor credentials or poor security around them, and the attackers being able to password guess and password spray and essentially break into those applications. The third bucket was the Supernova web shell, originally thought to be part of the same SolarStorm activity based on the fact it was closely coupled with the software, SolarWinds Orion, but it wasn't digitally signed, so it didn't come out of the build system as per the other activity, and it was an exploit was used to essentially overwrite an existing component in Orion to deliver this web shell, and that it essentially extended the HTTP API to allow remote control from the adversary. And in this case, it allowed them to send C# high-level language code across the network to this web shell, which was then compiled in memory and executed. So, very sophisticated stuff, believed to be Chinese adversaries that were using that in their attacks. And then finally, there were some vulnerabilities, I think at least publicly reported in February this year by Trustwave that were affecting the SolarWinds Orion software. I'm not too sure if much has been said about these again since, or whether they were used in any of the attacks that I've just mentioned. But certainly it was a difficult year, I'd say, for the SolarWinds Orion software and the attacks that we're seeing. What I'm actually going to focus on today is the Sunspot malware. That's the Trojan that was running inside the SolarWinds company in their build system, which injected the Sunburst Trojan, the backdoor, into the Orion software. Okay, so in terms of the timeline, I'm not going to talk about all of this in the interest of time, but if you look over there on the right in the blue, that's when FireEye published their blog about their breach. About 4 or 5 days later, they published another blog stipulating that it was the SolarWinds Orion software that led to that breach. And then pretty much everything else on this slide, at least to the left-hand side, was stuff that was retrospectively found through researching open source intelligence as well as closed source. And we've figured out when domains were stood up and when certificates were created, when files were compiled, when the actual when the supply chain attack happened. So the key area I want to focus on is February 20th, 2020, which is when the Sunburst malware was compiled and deployed into the build system. And that's essentially just before late March, about a month before when the software was available on the internet for auto updates for the Orion customers. It's worth noting as well, on the 12th of September 2019, so quite a while before, there was actually test code added by the actors into SolarWinds Orion, but it was benign. It effectively did nothing other than to test the fact that they had successfully breached the build system and managed to add some source code to the Orion project. And I guess the idea is that they would then wait for that version to be updated on the internet, they could then verify that their changes were in fact in the public version, and that gave them the confidence they needed to, to carry on with these attacks. So focusing on Sunspot, it's the piece that hijacked the SolarWinds build system to introduce the Sunburst backdoor to the Orion source code and then to the customers through the supply chain attack. So a very simplistic view of the SolarWinds build process is this, that the Orion software is written in C# and eventually becomes a .NET executable binary once it's compiled. And in the middle, there's a whole bunch of stuff that has to happen. In this particular case, they used Team City by JetBrains, which is a general purpose CI/CD solution that many organizations use to automate their development and build process. And they also use SonarQube, which is part of the QA process within there as well. So we learned about this, which is obviously quite internal information, through public domain. So one of the things we learned was that Team City reported on their website that SolarWinds was one of their customers. Whether or not the actors use this information, we don't know. But the more that companies publicize who their customers are and things like that, opens up the imagination of the attackers, if you like, to know who and where they need to target, or in this case, potentially what kind of systems they need to build to almost replicate what SolarWinds is using internally before they launch their attack. So it's almost giving them like a stepping stone or a helping hand in that sense. Secondly, we learned about SonarQube by looking at some of the malware code of Sunspot. And what was interesting, there were some lines of code, the two suppress message method calls here in this code snippet, that essentially suppress certain warnings or errors that would have been thrown when the actors injected their code and it went through the build system process. So clearly, they are sophisticated, they understand the build system, and they've managed to work in ways to suppress people finding out what's going on. So at a very high level, this is how the process worked. Once Sunspot was running on the compromised build system, we don't really know how it got there. I believe SolarWinds themselves, at least the last time I heard, had 2 or 3 options as to how they were potentially breached in the first place, whether it was a phishing email or some vulnerability that was exploited. But ultimately, when that software is running, it's monitoring the whole build system constantly, looking for conditions to be correct. Then when the conditions are correct, it would decrypt the Sunburst malware from within itself, from Sunspot, which is C# code, and it would deploy that into the build system for it to be built. And finally, the output would be this digitally signed, very trustworthy, as Eoin was alluding to, program that lots of customers use. So the conditions that have to be met are that Sunspot monitors for a process called msbuild.exe, which is part of the .NET Visual Basic build system. So only when that process is running is Sunspot actually going to care about anything. Once that's running, it can interrogate some of the file paths and file names that are being used in that executable process to understand that it's the Orion project being built and not one of SolarWinds' other software projects. And then they confirm that the source code has not been changed. So there was a source code file called inventorymanager.cs, which you can imagine is hundreds of lines of C# code. That's the one they targeted. And they worked on the premise that as long as that code didn't change, they knew that their version of that code, which was all of the existing Orion code plus their Trojan, the Sunburst Trojan, would work in the build system as they intended. If a SolarWinds developer had modified that code, then all bets were off. Essentially, they wouldn't know that overriding that file with their own would be a safe thing to do, and it may throw alerts and so on and give their game away. So it would decrypt the files, it would keep a backup of the original Orion software, override their one so it could be built. And then the final step was a cleanup. So once the build process was done and Orion was built, it would then delete the version of the malicious inventory manager.cs and replace it with the original benign one in case someone came looking. So the core goals of Sunspot was to avoid suspicion at all costs. So don't touch the source code repository. I imagine that they didn't want to do that because they would have had to get credentials. They would have been modifying source code that could be privy to like peer review processes. It could have been logged. There could have been many other things that went wrong if they tried to modify the code in, say, a GitHub or an SVN repository. So they went for the post SVN part, if you like, the build system. They didn't want to break the software, so they bailed out if any changes were seen that they didn't like, so any modifications to what they expected. They didn't want to throw any warnings and give the game away, so they suppressed error messages they knew would be thrown by their code. And they didn't want to leave a trace, so they wanted to delete the files they used and remove any other activity. And then finally, just to recap on SolarStorm and why it's important, just building on what Eoin said earlier, this is not the first supply chain attack we've seen. It's not going to be the last. And to his point, we've seen CodeCov being hit in the last 48 hours or so. It's not the first time security vendors have been attacked or governments. So why is this one so important? I think it's the stealth aspect of it. The fact it was built into Orion plugin, digitally signed, and there's that trust element to it. It waited a period of time before requesting access to the C2 so that it didn't, again, cause any disturbance. When it did communicate, it tried to mimic the traffic setup, if you like, or the packets of the Orion update protocol. The scalability was big. The privilege was really critical. The fact that they were on such a privileged system in such a privileged area of the network, so much of their hard work was already done for them. They didn't have to move laterally or elevate privileges. The dwell time was huge. It was months before they were detected. And even when SolarWinds Orion was removed, by then they've probably added additional backdoors and other web mechanisms to get back into the same organization. So it's a huge overhaul of someone's environment to verify if they were compromised or still compromised. And finally, yeah, the adversary nation state, very sophisticated, and they're in it for the long-term espionage and access to the network. Thank you very much for your time, and hopefully that was useful. And we'll go on to the Q&A. Thank you.
Thank you, Alex. Again, very informative. There is one question, I think, in the Q&A, and I know we're almost top of the hour. It's just, I think you mentioned, is it Liam Lynch has asked, didn't the US White House just attribute SolarWinds to the Russians, which I believe is correct, yes.
Yeah, they did. And actually, it came out pretty quickly at the time in December. I think they said APT 29, but most vendors' visibility like ours and Cylance and other people, I don't think we have the privy information that the government has.
Yeah, exactly. Okay, great, thank you. So unfortunately, we're short on time and I'm conscious of everyone's busy schedules. So we won't have much more time for Q&A, but we will be sending out a survey at the end of this to see if there's interest around this topic. So that it'll be shared in the chat window. When the session ends, you'll see the survey there as well. I'd really encourage people to, I suppose, fill that in and see if we want to focus on some other topics similar to this in the future. So with that, look, I want to first and foremost thank our speakers, Peace, Josh, Kieran, Eoin and Alex, who did a fantastic, really insightful talks today. Thank you to our attendees for joining. I really hope the session was of benefit to you all. So I suppose in terms of just next items happening from the South chapter, we are continuing our threat intel series, which Eoin mentioned at the start of the webinar. Our next session is, I think, towards the end of the month, the 28th. And I know Anya shared that link in our chat window there as well. And just in terms of what else we're going to be looking at, we are planning another webinar, Cybersecurity Career Promotion at Secondary Level, in May to build momentum ahead of our Cybersecurity Academy, which is due to take place June 8th. This is a 5-day event targeting 4th, 5th and 6th year students who want to learn the essential skills to identify, prevent and predict cyber attacks. I think we all know we need to build up that workforce given the importance around security. So with that, thank you all for joining and looking forward to our next sessions. Take care.